Good morning, everyone. Am I audible? Are you all able to hear me? Good morning, everyone. Good morning, everyone. Are we live? Please tell me in the chat section. Are we live? Are you all able to hear me? Hello, Richu. Hello. Hi, everyone. Good morning. Great, Richu. Hello, hello. Yeah, in yesterday's stream there was some problem while we were having our class. There was some internet issue, I think so. All right, so we'll continue that class today. Okay, there was some internet issue yesterday, I think so. So today we'll be covering this. All right, so a very good morning to everyone. I hope you all are good. You all are doing good. All right. Today we'll be continuing limiting reagent. Today we will be continuing limiting reagent only. All right. There are a lot of questions today which we are going to study. All right. So I welcome you all to India's largest education platform, Unacademy. This is Let's Crack NEET UG in English platform. Alright, this is an English platform. I welcome you all here. Alright, let me first introduce you myself. I am Nitesh Devnani. I have 5 years of teaching experience in chemistry and I have taught over 2000 plus students who have got some great marks in NEET examination. Hello Ritu. Hello. Alright, so let me tell you about the subscription plan. Let me tell you about the subscription plan of Unacademy. What are the benefits of it and what you will get when you subscribe to Unacademy's subscription plan. Alright, first of all, you need to download this app, Unacademy learning app. You will get all the information, your subscription related as well as your free classes also on this app, Unacademy learning app. So download this app after this class. All right, so see, there would be live classes, there would be live tests and as well as quizzes. There are structured courses as well as you will have unlimited access. Unlimited access means you will be able to attend your classes. You can be able to watch the recorded lectures also afterwards whenever you are comfortable. All right, so see, there are free classes also. All you need to do is you need to download Unacademy learning app. All right, just download this app, Unacademy learning app, and you will be able to access everything. Okay, so these are the top educators for the NEET platform and UG platform. All right, so let me tell you about the pricing thing. So if you subscribe, whenever you subscribe, you just need to apply this code Nitesh YT. Nitesh is my name, you need to remember this, and YT. So you will get additional 10% off. So I would recommend you to either go for 12-month course or 24-month course. Alright, 12-month course would be of around 27,000 and 24-month course would be at around 32,400 rupees after applying my code Nitesh YT. Nitesh YT. Alright, yes Ritu, it is YT. I don't know, YT must be for YouTube. Alright, so Nitesh YT you will apply, you will get 10% off. Alright, this is my code. Great. So today we are again going to have Raghu. I really don't know about this particular thing which you are asking. Let me confirm today, then I'll let you know. Okay. Hello Sajjan, hello Ritu, hello Raghu, hello Devaki, hello Sajjan. How are you all? How are you all, buddies? All good? Okay, so today we'll be covering our limiting reagent topic. In yesterday's class there was some issue regarding some internet. So today we will be covering limiting reagent and the next day we will be taking the classes of organic. So we are having daily class at daily one class at 11 a.m. All right, at 11 a.m. One day we are having physical chemistry and the other day we are having organic chemistry, and we are covering entire syllabus. In between I will also take your inorganic chemistry also. So but right now we have at 11 p.m. regular classes. One is of physical and one is of organic chemistry. One day physical, one day organic. So today we are going to study physical chemistry, limiting reagent, mole concept. All right, very interesting topic. A lot of questions we are going to do, and you are going to attempt these questions. All right, you are going to attempt all these questions. So just take out your copy and pen. Okay. um Great, Raghu. Sajjan and Richu, today we are going to study physical chemistry. Tomorrow's class we will be studying organic chemistry. All right. Tomorrow we will study organic chemistry. We will further take our topics. All right. So first, let me tell you what is limiting reagent. First, let me tell you what is limiting reagent. You guys just need to attend the complete lecture, and I promise you, you will be very much able to do all the questions of today's topic from any book you can take. All right. So just you need to attend the complete lecture, complete video, and just take your copy and pen with you. All right. Today you are going to do a lot of questions. Yes. Good morning, Arya. Good morning. Good morning, Ankit. Great. All right. So see, now suppose today you are in the mood. You are in the mood to manufacture water. Suppose you are in the mood to manufacture water. You need to form water. All right. So to form water, you need H2 and O2. Correct. You need hydrogen and oxygen to form water. Correct. Right. Please like this video, everyone, if you are very much able to understand what I explain on this channel. So please like this video. All right. Now suppose you want to make water, so you need hydrogen and oxygen. Correct. Now suppose initially you have brought 100 moles of hydrogen and you have brought just 5 moles of oxygen. Now just balance this equation. See, for balancing this equation you need to just do hit and trial. Okay, so this was a very easy equation. We have balanced this equation. So for limiting reagent also, first step is to balance the reaction. All right, I have balanced the reaction, and 100 moles you have brought of hydrogen, 5 moles you have brought of oxygen. All right. Now see, what are these? This 2, this 1, and this 2. What are these? These are known as stoichiometry. These are known as stoichiometry coefficients, such that, see, stoichiometry coefficient of hydrogen is 2, stoichiometry coefficient of oxygen is 1, stoichiometry coefficient of H2O is 2. All right, this much is clear to you. Now see, what does stoichiometry tells us? Stoichiometry tells us that 2 moles of hydrogen combine with 1 mole of oxygen to form 2 moles of H2O. Means stoichiometry coefficient tell us about the ratio in which reactants are reacting and the ratio in which products will be formed. All right. Sajjan, this is physical chemistry only. We are studying physical chemistry only right now. All right. Now see, for 1 mole oxygen, see, the stoichiometric coefficient is 1 of oxygen. You need how many moles of hydrogen? 2. 2 moles of H2 are required. Correct. Stoichiometry is telling us about this. Alright, but how many moles of oxygen you have brought? 5 moles. So therefore, for 5 moles oxygen, how much H2 would be required? Tell me. How much H2 would be required? Raghu, we will be completing this course in around 4 to 5 months. Just first tell me how much hydrogen would be required. For 5 moles you would be requiring 10 moles of H2. Correct? Correct? Yes. Got it. But how much moles of hydrogen you have brought initially? 100 moles. But you only require 10 moles. Therefore, hydrogen would be left in the reaction. When reaction completes, see, all the 5 moles of oxygen would be consumed. Alright. So therefore, all oxygen is consumed. Why? Because it is in lesser amount. So all oxygen would be consumed. And hydrogen H2 left. Hydrogen left would be, see, you have brought 100 moles initially. You just need 10 moles. So 10 moles are consumed. So hydrogen left is 90 moles. And oxygen is completely consumed. Alright. So in this particular reaction, just please wait. In this particular reaction, oxygen is known as limiting reagent. Why it is known as limiting reagent? Because it is consumed first in the reaction. It is completely consumed in the reaction. So therefore, the reaction stops because of this. Why? Because there is no oxygen right now. If oxygen is not there, you cannot manufacture water. Got it? So that's why oxygen in this case is known as limiting reagent. It limits the reaction. It stops the reaction. Alright. And the reactant which is left, hydrogen is left in this case. How many moles? 90 moles. So this is known as excess reagent. The meaning excess means it is in very much large quantity. Alright. Are you getting my point? Yes, Sajjan, we'll take inorganic chemistry also in between. Yeah. So just give me a thumbs up in the chat section and also like this video if you are very much able to understand all this thing. So see, this was a basic understanding of limiting reagent. What is limiting reagent? This was basic understanding. Let me give you proper definition of it now. Limiting reagent. Limiting reagent. Let me give you proper definition. Alright. Limiting reagent is that reactant which is consumed first in the reaction. That means it is that reactant which is first completed in the reaction, which is totally consumed in the reaction. It is that reactant. And the second reagent was excess reagent. Alright, is that reactant which is left in the reaction. This is left in the reaction. See, limiting reagent is the one which is consumed in the reaction. Alright, and excess reagent is the one which is left in this reaction. So in this particular example, your O2 was your limiting reagent and H2 which was left, how much moles? 90 moles of hydrogen were left. So this is known as excess reagent. Are you able to understand? Great, Sonam, Ritu, Santosh, Sajjan. Great. Just give me a thumbs up in the chat section if this much is clear to you. Come on. Just give me a thumbs up. Alright. See, so we have understood what is basic definition of limiting reagent, and the basic understanding of limiting reagent we have understood. Raghu, we have started from last week. Alright, so you can watch those lectures if you have missed it. There are recorded lectures here only on this channel only. Alright, now mathematically, now let me tell you mathematically how do we calculate limiting reagent. How do we calculate, or rather how do we find limiting reagent. There would be lot of reactants, 2, 3, 4 reactant. We need to identify which reactant is limiting reagent. All right. Now let me write first this note for you all. That reactant is limiting reagent means LR. That reactant is LR means limiting reagent. All right. That reactant is LR whose number of moles upon stoichiometry coefficient, whose number of moles upon stoichiometry coefficient, the ratio of number of moles upon stoichiometry coefficient is lowest, your smallest. See, there would be many reactants given to you. All right, you need to find their moles. We know how do we calculate moles by if mass is given, we can calculate it. If particles is given, we can calculate it. If volume is given, we can calculate it. We have completed that in our lecture 2. All right, and you just need to divide it by stoichiometry coefficient. Now what is the condition? Come on everyone, tell me in the chat section what is the first step you need to do in order to completely solve a limiting reagent questions. Come on, what is the first step you need to do? Tell me in the chat section what is the first step. First step is to balance the reaction. Yes, you need to first balance the reaction, then only you will be able to determine their stoichiometry coefficient, then only you will be able to find this ratio of number of moles upon stoichiometry coefficient. Is this much clear to you? Great, Ritu, great. You guys need to be very much active on the chat section. All right, I'm continuously, see, I have my phone with me, I'm continuously monitoring chat section. All right, great. Now let us do some questions. Are you guys ready for the question? I am going to mix some questions also. Later on in the class we'll mix some questions also. We will mix limiting reagent with stoichiometry also. I'll give you proper differentiation between when you need to apply limiting reagent concept and when you need to apply stoichiometric coefficient. You just need to be very much active and very much attend the complete class. All right, okay. Now let me give you question. 12 gram of H2 reacts with 64 gram of O2. Find limiting reagent. Let me do this question for you all. The rest of the questions you are going to do it for me. All right. So first, see, hydrogen and oxygen are reacting. First you need to write the reaction. So H2 plus O2 reacts to form H2O. Please understand this method once and then you will be very much able to do all the questions. All right, let me first balance this. Now please understand this method. The way I am doing it, you also need to do this the same way. All right, see what is given to you. 12 gram of hydrogen, just write 12 gram below hydrogen. What is given to you? 64 gram of oxygen, just write below it. All right, now we don't deal in mass, we don't deal in particles, we don't deal in volume. We need to calculate moles. So how do we calculate moles? Moles would be given mass 12 upon molecular mass of hydrogen is 2. So how much? 6 moles. Moles of oxygen given mass 64 upon molecular mass is 32. So how much? It is 2. Got it? Now just draw this line. Always. Now here we are going to do our rough work. Rough work means how to find limiting reagent. I've just written. Just do this way only. You will never make any mistake. All right, if you do this way. Now see, what were the moles you have calculated? 6 moles. what do we need to do? We need to find limiting reagent. For limiting reagent, we need to find the ratio of number of moles upon stoichiometric coefficient. So the number of moles here are 6. Stoichiometric coefficient is of hydrogen is 2. So 6 by 2 is 3. Number of moles here is 2. Stoichiometric coefficient is here is 1. If nothing is written, it's 1. It's 1. So this comes out to be, the ratio is coming out to be 3 and 2. You need to find the smallest ratio. So smallest ratio is 2. So this oxygen is your limiting reagent. Lr is oxygen. Okay. Now if limiting reagent is oxygen, then the other reagent which is left, in this case hydrogen, this must be what? Excess reagent. Excess reagent. This is known as ER. Alright. So you have calculated limiting reagent is oxygen, excess reagent is hydrogen. Alright. We are just right now focusing on how to calculate, how to find a limiting reagent. The other part would be, see, hydrogen is excess reagent. You got it? Hydrogen is excess reagent. So excess reagent means this some amount of hydrogen must be left after this reaction. That's why it is in excess. Na? So later on in this video, I will tell you how do we find these this amount of excess reagent left and the amount of product also formed. I will tell you later on in the class. Right now let us focus on how do we calculate, how do we find limiting reagent. That is very, very important. Are you getting my point? If you are able to understand this question, just give me a thumbs up in the chat section. Come on everyone, just give me a thumbs up in the chat section if you are very much clear with it, what I have taught you till now. Great Ritu, fantastic. Everyone, please be active on the chat section. Great. Let me give you one more question then. Let me give you one more question. Let me give you one more question. Great, Richu. Great. All right. Great. Let me give you another question. 12 gram of hydrogen reacts with 28 gram of nitrogen to form ammonia. Find limiting reagent. All right, come on, find limiting reagent. Tell me in the chat section which one is the limiting reagent. Tell me in the chat section. Come on. You need to tell me in the chat section which one is limiting reagent. First write the equation, then balance the equation, and then move further. Let me write equation for you all. Nitrogen plus hydrogen reacts to form ammonia. Balance this. See, there are 2 nitrogen. You need to write 2 here. Now 2 into 3, 6 hydrogen. You need to do 3 here. The reaction is balanced. Tell me in the chat section limiting reagent. Everyone be active on the chat section. Come on. And also like this video. Yes, tell me. Okay, Ritu and Richu have given their answers. Everyone, please be active on the chat section. Okay. Come on, everyone, give me your answers. Just write whatever is given to you. 12 gram hydrogen is given. So 12 gram hydrogen. Alright, 28 gram nitrogen is given. 28 gram nitrogen. You need to convert them into moles. We are only dealing in moles. Alright, so 28 given mass upon molar mass of nitrogen. Sorry, nitrogen gas. Yes, 14 into 2, which is again 28. 28 upon 28, which is what? 1 mole. So now moles of hydrogen given mass upon molar mass. Molar mass is 2. So this comes out to be 6 moles. Got it? Now just draw this line. Now just draw this line. Alright. Now we write here how to find LR. How to find limiting reagent. How do we find it? Number of moles 1 upon its stoichiometric coefficient is what? 1. 1 by 1 is 1. Number of moles 6 upon its stoichiometric coefficient 3 by 3. So this comes out to be 2. So 1 and 2, the smallest is 1. We circle it and we write here limiting reagent. If N2 is your limiting reagent, hydrogen would be your excess reagent, ER. Got it? Is this much clear to you? Great. Richu, Ritu, Santosh. Yes. Is this much very clear to you? Very, very good. Very good. Please be active on the chat section, everyone. 8 students are watching this right now, but only a couple of them are answering it. You need to be active on the chat section. I should be able to understand that you guys are very much clear with this concept. If not, you can surely ask me doubts also. Okay. Okay, one more question. Let me see if you have really understood this lecture or not. Equal volumes of hydrogen and nitrogen react to form ammonia. Find limiting reagent. Find limiting reagent. Come on, try this again. Try this question. Great, Arya, great. Come on, everyone, try this question. Just first write this equation and balance the equation. Hydrogen, we have written just the same equation right now. NH3, balance this. This is balanced. Alright, equal volumes. Let us see. Yes, we'll check. Everyone, write your answers on the chat section. Everyone, write your answers on the chat section. I'll explain you everything. Equal volumes of hydrogen and N2 react to form NH3. Equal volumes. So let the volume be V. If the volume is equal, I am assuming it to be V liter. I'm assuming it to be V liter. Is this clear to you? Equal volumes, I can assume it to be anything. 100, 200, 500, 1000. I am assuming it as V. Alright. Okay. Yes, Ritu. See, now see, this has V liter. Alright. This also has V liter. Now we need to convert this liter, V liter, and in moles, equal volumes of H2 and N2. Now how do we calculate? This volume with the how do we calculate moles from volume? You just need to multiply volume upon 22.4. You just need to divide it by volume upon 22.4. Alright, now you have your moles. Now what do we do? Now we write here how to find limiting reagent. Alright, how do we find it? V, number of moles upon its stoichiometric coefficient is 3. Alright, number of moles upon its stoichiometric coefficient, which is what? 1. Now tell me which one is smallest. Come on, tell me which one is smallest. Yes, Richu, we will complete entire physical chemistry. Raghu, regular classes are at 11 a.m. 11 a.m. Tell me which one is limiting reagent right now? Yes, Richu, we will complete it. No, no. Tell me, V upon 22.4 or V upon 22.4 into 3? Which one is smallest? This one is smallest, na? Because it has larger denominator. Its denominator is more. So this would be smallest. So your hydrogen would be your limiting reagent. Your nitrogen would be your excess reagent. Because here the denominator is large. So if the denominator is large, the overall ratio becomes smaller. So limiting reagent is hydrogen. Excess reagent is nitrogen. Is this much clear to you? Is this much very clear to you, all of you? Tell me in the chat section. Okay, now let me give you one more question. Let me give you one more tricky question. Let us see if you are very much able to understand this. This much clear to you? Give me a thumbs up in the chat section. Then only I will move forward. Great, Arya, Santosh, Richu. Fantastic. Raghu, Ritu, are you able to understand this? Rinkya ke papa. Great. Okay. Okay. Again, some more questions. Question is 28 gram of N2 reacts with 6 gram of H2. Find limiting reagent. Again, in this question you will understand one more important thing. Alright, all the questions are giving you something to learn. Alright, you just need to grasp those things. Come on, try this question. Write this equation. We have written it couple of times in today's lecture only. Come on everyone, try this question. I'll be waiting for your answer. Okay, we'll see. Come on everyone. What is the difficulty you are facing here? What is that difficulty which you are facing here? Come on, tell me in the chat section. What is the difficulty you are facing here? Okay, just write down whatever is given to you. 28 gram nitrogen is given. 28 gram nitrogen. Hydrogen is 6 grams. Hydrogen is 6 grams. Alright. We don't deal in weight. We don't deal in particles. We don't deal in volume. We need to find their moles. Yes, Arya, great. Richu, Santosh, Ritu, let me. That's why I'm giving you all type of questions so that every concept is cleared. All right, great. So now we need to calculate their moles. Got it? So to calculate moles, given weight upon molar mass of nitrogen is 28. This comes out to be 1. Moles is 6 upon molar mass of hydrogen is 2. This comes out to be 3. Now just draw this line. Alright, just write how to find limiting reagent. How to find limiting reagent. What was the trick? Number of moles 1 upon its stoichiometric coefficient is 1. 1 by 1 is 1. Number of moles 3 upon its stoichiometric coefficient is 3. So this is also coming out to be, now both the ratios are coming out to be 1. Now we cannot differentiate between them which one is smaller, right? So in this particular case, when both the ratios are same, we say there is no limiting reagent. There is no limiting reagent. There is no limiting reagent in this case. If this happens, the both the ratios are coming out to be same, we say there is no limiting reagent. Is this much clear to all of you? Arya, Ritu, Santosh, is this much very clear to you? Because both, we cannot differentiate between them which one is smaller. To find limiting reagent, we need to know which one of them was smaller, but in this case we cannot differentiate them. If we cannot differentiate them, we just simply say there is no limiting reagent. This much clear to all of you? Tell me in the chat section. Come on everyone. Great, Arya. Yes, Santosh, Ritu, fantastic. Great. You all are learning very good. Fantastic. Great. Okay. Now see, in we have just taken 4 questions. In all those questions, I have just taught you how to find limiting reagent. Again and again, we are talking about same thing, that how to find limiting reagent, how to find limiting reagent. Now we will see how to find excess reagent left and product formed, right? See, product would see limiting reagent is the one which is consumed first in the reaction. Excess reagent would be one which is left in the reaction, suppose, right? So we need to find how much excess reagent is left in the reaction, and we need to find how much product is also formed. Now we are going to do remaining part of this today's class. All right, very important. I will again explain you with the help of a question. All right, you just need to be very much aware. You just remain very much aware with me. All right, question is 64 gram of O2 reacts with 12 gram of H2 to form water. Now see, now please pay attention. It is asking find, there are 3 parts of this question. Find, first part is limiting reagent and excess reagent. All right, you guys can attempt now first part. All right, second part is moles of excess reagent left. This is the second part. And the third part is moles of H2O formed, means the product H2O, how much moles is formed. These 3 questions, these are the only 3 questions which any question in which any book or any exam can ask from you. Only these 3 type of questions are being asked. All right, first type of, in this first part you can now easily calculate. Now let me solve all these 3 parts again for you, very detailed we will solve it. Then all the questions you are going to do, you will be very much able to do it. All right, so first let me write this equation. First let me write this equation. Let me balance this, because the first step was to balance. What is given to us? 64 gram O2 and 12 gram hydrogen. So let me write 12 gram here and 64 gram here. Got it? Now we need to convert them into moles. So the number of moles would be calculated as 12 upon molecular masses of hydrogen is 2. This is 6. Moles is 64 upon molecular mass is 32. So this must comes out to be 2 moles. Alright. Now we have calculated 2 moles. Now what do? We just draw this line. You always need to draw this line. Alright. Then only you will be very much clear with all the things. Please pay attention here. I am writing how to find limiting reagent. How to find limiting reagent? How do we calculate it? Number of moles upon its stoichiometric coefficient, which is 2. This comes out to be 3. Number of moles upon stoichiometric coefficient, which is 1. So which is limiting reagent? Which one is limiting reagent? This one is limiting reagent. This one is limiting reagent. All right. And if this is limiting reagent, this is your excess reagent. Just close this line now. All right. This much clear to you. You have find limiting and excess reagent. Now, what are great Kalai? Okay. Molecular masses are, most of them would be given to you, but you need to now understand, you need to learn molecular masses. Okay, the common molecular masses you must be you need to learn it. Now what was our second question? Please pay attention here. Amount of excess reagent left and amount of water formed. So see, always the amount of excess reagent left and the amount of water formed, this always depends on limiting reagent. Always the amount of excess reagent left and the amount of water formed would always depend on limiting reagent. All right, now let me write. You must be remembering that magical equation of stoichiometry. You must be remembering that magical equation of stoichiometry. Now let me write that magical equation for all of you. All right, so this is the equation you have. So magical equation is number of moles of hydrogen upon its stoichiometric coefficient, which is 2, equals to number of moles of oxygen upon its stoichiometric coefficient, which is 1, equals to number of moles of H2O upon its stoichiometric coefficient, which is 2. All right, this was the magical equation. Now in limiting reagent case, you have excess reagent. Excess reagent is the one which is left in the reaction, which remains in the reaction. So for the excess reagent, you need to write here reacted. How many moles of excess reagents are reacted? Now please pay attention here. Now I am equating these two things. First I need to find how many moles of H2 reacted. I am equating these two things. So just pay attention here. Number of moles of H2, but this time it is reacted, upon 1 equals to number of moles of O2 upon this is 2 and this is 1. Okay, what was the number of moles of oxygen? The number of moles of oxygen which we have calculated is 2. Okay, so number of moles of hydrogen reacted equals to 2 by 1. This is the thing, we have just replaced this number of moles with 2. So number of moles of hydrogen reacted are coming out to be 4 moles. Yes, now just look at the number of moles of hydrogen which you have initially brought. You have initially brought 6 moles. Now we know only 4 moles are reacted. That's why number of moles of H2 left would be 6 were initial, 4 are reacted, so left is 2 moles. Great. Are you able to understand this? There is simple one difference. You just need to write there. In the case of excess reagent, you just need to write reacted. Now just calculate the number of moles reacted. Subtracted with the initial moles, you will get the number of moles left. Now let me give you the third part of our question was number of moles of H2O formed. Again, now I will calculate O2 and H2O. Always use limiting reagent. Why we are taking O2 only? Because O2 is our limiting reagent. Alright. Now number of moles of O2 upon 1 equals to number of moles of H2O by 2. Number of moles of O2 are 2. 2 by 1 equals to number of moles of H2O by 2. So number of moles of H2O are 4 moles. Got it? So the 4 moles of H2O are formed and Hydrogen, which was our excess reagent, left is 2 moles. We have answered all the questions. Is this much clear to you? Great, Rajni, Ritu, Arya, Kalai. Kalai, there are regular classes at 11 a.m. We have our regular classes at 11 a.m. Great, Santosh. Is this much clear to all of you? I am again going to take, we are going to take lot of examples. Okay, don't worry. I will explain you today limiting reagent, the complete concept. You don't need to worry about it. Okay. Is this much clear to all of you? Just give me a thumbs up in the chat section if this is clear to all of you. All right. Great. Great, great, great. Fantastic. Fantastic. Now let me give you one more question. You need to attempt that particular question. 28 gram of nitrogen reacts with 14 or let's suppose 16 gram of hydrogen. You need to find all the three things: limiting reagent and excess reagent. These three type of questions are only asked. All right. Amount means weight of excess reagent. ER is excess reagent left, and weight of NH3. NH3 is product formed. Come on everyone. Yes. Great. You guys are learning fantastic. Come on. Attempt this question. First write this equation, balance this equation, try to find limiting and excess reagent, then proceed further. Always, once you have your limiting reagent, always use that magical equation and equate it with limiting reagent part only. Come on everyone. Yes. Lot of questions we are going to take today. Alright. Later on in the class, I'll be telling you difference between limiting and excess reagent. The difference in questions of limiting reagent and stoichiometry also. Alright. So just attend this lecture completely. You will be very much clear with each and everything. Great. Come on. I am waiting for your answer. I am in no hurry. I am in no hurry of anything. You properly do this complete question. I know it takes time. Initially, to get hold of these things, it will take some time. Alright. But after that, once you have the hold of this method, you will be very much able to solve all the questions. No problem. Great. We'll see Richu. We'll see Rajni. Take your time, guys. Take your time. We are in no hurry. If you are able to understand all these things, just like this video. Amount means you need to find weight. You need to find weight. How much weight is formed. Come on, everyone. First of all, you need to write equation. You need to write the equation. N2 plus H2 reacts to form NH3. balance this equation. Whatever is given to you, 28 grams here and 16 grams here, whatever is given to you, just write that thing. Come on everyone. Okay, we'll see. Ritu, Rajni, Richu, everyone write your answers. Let me see. Let me see. Come on everyone. Alright, let me explain you. Let me explain you. Just simply write, just simply convert them into moles. This is the same thing we are doing again and again. 28 upon molar mass of nitrogen is 28. This comes out to be 1 mole. Number of moles 16 upon molar mass is 2. So this comes out to be 8 moles. Alright. Now what do? We just draw this line. Alright. What do? How to find limiting reagent? Number of moles is 1 upon stoichiometry coefficient is also 1. 1 by 1, 1. Number of moles is 8. Stoichiometry coefficient is 3. So this is 8 by 3. Now 8 by 3 and 1. So which one is smaller? 1 is smaller. Alright. So this is your limiting reagent. This is your excess reagent. Alright. This much clear to you? Now let me write that magical equation. What was the magical equation? Number of moles of N2 upon its stoichiometric coefficient, which is 1, equals to number of moles of H2 upon its stoichiometric coefficient 3, equals to number of moles of ammonia upon its stoichiometric coefficient, which is 2. Got it? Now what do you need to do? You need to write here reacted, because this is our excess reagent. Just simply write reacted. Now we need to take help of our limiting reagent to find amount of excess reagent left and products formed. Just equate first these two. How do we do it? Number of moles of N2 upon 1 equals to number of moles of hydrogen reacted by 3. Correct? So what was the number of moles of nitrogen? See, we have calculated here 1 moles. Here 1 by 1 equals to number of moles of H2 reacted upon 3. So number of moles of hydrogen which are reacted is coming out to be 3 moles. But initially you have brought how many moles? 8 moles. Correct? So number of moles of H2 left would be 8 minus 3. This comes out to be 5 moles. See, if moles are asked to you, 5 is the answer. But you are asked whether you need to find weight. So simply, if you have your moles, simply weight of H2 left would be, simply multiply this. Just wait a second. Yes. Please wait a second. Yes. You need to find weight. Alright. The weight was asked to you. If the number of moles would have been your 5 would have been your answer. But you are asked, you need to find weight. So simply multiply this weight with its molar mass. Molar mass of hydrogen is 2. So this comes out to be 10 gram. 10 gram. 10 gram is left now. 5 moles of hydrogen are left. So 5 moles means 10 grams. You need to multiply this with molar mass. 2 is your molar mass. Now this is clear to you. Now tell me ammonia formed. How much ammonia is formed? Ritu, Santosh, Kalai, Rajni, Richu, is this clear to you now? Tell me in the chat section if this much clear to all of you or not. and try to find now ammonia formed. All right, great. See, I try to find ammonia. Come on. See, I am again and again telling you this is a learning process. All right. If you are not able to do questions right now, but don't worry, after this class, you will be very much clear with all these concepts. Everything is a learning process. All right. We just need to continuously learn things. That is our main goal. All right. Try to find ammonia. How much ammonia is formed? Come on, everyone. Try to find it. I'm taking more questions. You don't worry about it, buddy. Try to find ammonia. Always use limiting reagent. This was your magical equation. Now equate. This is your limiting reagent, nitrogen. Equate this with ammonia. How much ammonia is formed? Number of moles of N2 upon 1 equals to number of moles of ammonia by 2. How many number of moles of nitrogen? 1. So 1 by 1 equals to number of moles of ammonia by 2. Number of moles of ammonia is 2 moles. Got it? So weight of ammonia would be simply multiply this with moles with their molar mass. Molar mass of ammonia is 14 plus 3 into 1, which is 17. So 2 into 17, this comes out to be 34 grams. Is this much clear to all of you? Great. See, now you are able to do now. This is all a learning curve. All right, this is all learning curve. Great. Now let me give you some more questions. Are you all, first tell me, are you all ready for the next question? Are you all ready for the next question? Are you all ready for the next question? Give me a thumbs up in the chat section. All right, you guys are ready. You guys are pumped up. I am also pumped up. Come on, just take out your copy and pen and finish this question. Come on, everyone. 4 gram of hydrogen reacts with 20 gram of oxygen to form water. Find amount is weight, amount of water formed. Only one question here, no three questions, only one question here. Come on, everyone. Yes, this would be a bit calculative, but you need to give me correct answer. You need to give me correct answer. Come on, let me see. This session was started at 11 a.m. We are having regular classes at 11 a.m. Regular classes at 11 a.m. Regular class. All right, you guys can attend this regular sessions. Come on, everyone. Yes, answer this. Simply write the question, write whatever is given to you, then try to find limiting reagent, and then try and then move forward. All right, slowly and gradually. H2 plus O2 would give you H2O. All right, balance this equation. I am just writing this equation. I need answer today. I need answer today. Richu, see your calculations. Sunitha, we are having regular classes at 11 a.m. We are having regular classes at 11 a.m. Class started at 11 a.m. Richu, check your calculations. Check your calculations. Come on, everyone. Let me see you all. I know you all are very much capable of doing it. Give me an answer. See your calculation, Santosh, again. Okay, Hadek and Rajni have given their answers. Let us check, na? Let us check. Let us see. Everyone, please be active on the chat section. Come on. Please be active on the chat section. Good afternoon, Royal Channel. Come on, everyone. Just simply write here. This is 4 grams. Here it is 20 grams. Alright. Whatever you first convert them into moles. 4 upon molecular mass of hydrogen is 2. This comes out to be 2. 20 upon molecular mass of oxygen is 32. So this I'm leaving like this only. Okay, we can solve it. We can cancel it with 4. Alright. So 5, 8. This comes out to be 5 upon 8. Alright. Alright. So now, okay, great. Yes. Now, what do? We write how to find limiting reagent. Correct. Simply we do how to find limiting reagent. How do we do it? Number of moles upon its stoichiometric coefficient is 2, 1. Alright. The ratio is coming out to be 1. Now we do the number of moles 5 upon 8. Number stoichiometric coefficient is 1. So divided by 1. This comes out to be 5 upon 8. Now tell me 1 or 5 by 8. Which one is smaller? 1 or 5 by 8. Which one is smaller? Which one is smaller? 5 by 8 is smaller. So this is your limiting reagent in this case, and this is your excess reagent. 5 by 8 is less than 1. Alright, great. Now what do we need to find? We need to find amount of water formed. We just need to find how much water is formed by this reaction, by this equation. Alright, so what do we need to do? We need to make use of our limiting reagent. So number of moles of O2 upon its stoichiometric coefficient is 1 equals to number of moles of H2O upon its stoichiometric coefficient is 2. You can do it directly also. Simply do this thing directly. Alright. Now number of moles of oxygen. Were 5 by 8. Okay. So 5 by 8 upon 1 equals to number of moles of H2O upon 2. You can cancel out these things. So number of moles are coming out to be of water 5 by 4. Now you don't need to find moles, you need to find weight. So weight of H2O would be moles into its molar mass. Molar mass of water is 2 into 1 plus 1 into 16. This comes out to be 18. Again you can do some calculations. This is 9. 5 into 9, 45 by 2. This comes out to be 22.5 grams. See, the calculations weren't, they were not tough. See, this much calculations in mole concept, you need to do these much calculations. All right, mole concept is a numerical chapter, so you need to do these type of questions. Is this much clear to you? Is this thing very clear to all of you? Tell me in the chat section. You don't need to do wrong calculations. Alright, no need to do wrong calculations. Great, Kalai. Just give me a thumbs up in the chat section, everyone. Come on. Everyone give me a thumbs up in the chat section if this much is clear to you. Great, Santosh. Great, Kalai. Don't worry about that you are not able to solve right now. Alright, see, these things take some time. Alright, so you need to be patient with it. We are doing great a large number of questions. Great, Richu, Hadik, Ritu, Rajni, Santosh, Kalai. Fantastic. Are you ready for the next question? Come on, everyone, tell me in the chat section, are you all ready for the next question? Are you all ready for the next question? Just give me a thumbs up. Just like this video if you guys are ready. Great. Fantastic enthusiasm. You guys are pumped up. I am also pumped up. Let me give you one more question. Let me see who all can do it. 10 gram of hydrogen reacts with 64 gram of oxygen. Find number of moles of H2O formed. Come on everyone, let me see who all can do it. Great Sunita, great Richu, great Kalai, we are always there for you. I'm always there for you. You can search my name on YouTube. You'll get a lot of videos there also. All right, great. Come on. Come on everyone. Attempt this question. Hello Subharaj, how are you? Great Subharaj, we are having regular classes at 11 a.m. 11 a.m. we are having regular classes. You can attend those classes regularly on this channel only. Come on everyone, tell me what should be the answer. What should be the answer of this question? Give me your answer. Yes, give me your answer. What should be the answer according to all of you? What should be the answer? You need to find number of moles. You need to find the number of moles. Some students have given their answer, others are doing. I'm waiting for everyone to give answers. Majority students are saying 4 moles. Majority of them are saying Santosh, you need to find moles. You need to find moles. No, Richu, you are only talking about right now products formed. You just check the reactant. Excess reagent is also left, na? So you need to add mass of that also to balance total mass of conservation. Got it? Now let me explain you. I will explain you your doubt also. Richu, I will explain your doubt to everyone. Just see here. H2O. Alright, this is your reaction. This is your reaction. Alright, 10 gram of hydrogen, 10 gram of hydrogen, 64 gram of 64 gram of oxygen. Now what do we need to do? We need to convert them into moles. Weight given based upon molecular mass is 2. This comes out to be 5 moles. Given weight 64 upon molecular mass is 32. This comes out to be 2 moles. Alright. Now what do? We just simply draw this line. Everyone just draw this line. Alright. This is very important. How to find limiting reagent? How do we find it? Tell me. How do we find it? Number of moles upon its stoichiometric coefficient, which is 2. This comes out to be 2.5. Number of moles 2 upon its stoichiometric coefficient, which is 1. So this comes out to be 1. Now 2.5 and 1, which one is smaller? 2 is smaller. So this is oxygen is your, just wait, this oxygen is your limiting reagent and this is your excess reagent. Got it? First tell me, I hope so you have got this much correct. You are very much able to determine limiting and excess reagent. This much clear to all of you. Now what do we do? With the help of our limiting reagent, we will find water formed. We need to find water formed. Just write the magical equation. Number of moles of oxygen upon its stoichiometric coefficient is 1 equals to number of moles of H2O formed upon its stoichiometric coefficient is 2. 2. Alright. How many moles of oxygen? See, how many moles of oxygen? Initially 2 moles. So 2 by 1 equals to number of moles of H2O by 2. So number of moles of H2O formed is 4 moles. We need to find moles only. We have our answer. Alright. Now see, if I calculate weight, what do I need to do? Moles into its molar mass, which comes out to be 72 gram. Alright. Now see, Richu was asking this one question which many of you might be having a doubt. See, here there is 10 gram hydrogen, 64 gram oxygen. So you are having 64 plus 10, 74 gram of reactants. Got it? Alright. Now in the product, you are only getting 72 grams. Right, 74 grams reactant, but in the product you are getting 72 grams only. So there is this excess reagent. Now this is not completely consumed in the reaction. No, some amount of excess reagent is also left. So if you calculate, so see, the initial mass was 74 grams. Now you calculate final mass. Final mass is of this excess reagent left and this product formed. So if you will calculate this, this will also again come out to be 74 grams only. Alright, is this much clear to all of you? Mass is always conserved in a chemical reaction. The law of conservation of mass tells us that mass of reactant is equal to mass of products, correct? So only exception of, tell me, I have taught you this in our lecture, in our previous lectures. Tell me what is the only exception of law of conservation of mass? What is the only exception? What is the only exception? Your only exception were of nuclear reactions. In nuclear reactions, law of conservation of mass is not valid. Otherwise, it is always valid. All right. Yes. Sunita, we are having our classes from last week only, so not a lot of classes are being missed. You can watch the recorded lectures here on this channel. Great, Ritu, fantastic, great. All right, I've explained you this thing in very detail. Now let me relate two very important concepts. We are relating stoichiometry versus limiting reagent. Stoichiometry versus limiting reagent. We are going to compare these two things. All right. Okay. Let me give you one question with it. You find this question, then I will come on to my topic, stoichiometry versus limiting reagent. All right. See. 8 gram of or 18 gram of hydrogen reacts with oxygen to form water. Find number of moles of water formed. Come on everyone, do this question. Come on everyone, try to do this question. This just please wait for 10 to 15 minutes more. You will be very much clear with this whole concept. Write this equation. What is the equation? H2 plus O2 reacts to form H2O. either here 2, here also 2. This is 18 grams. This is 18 grams. All right. Okay, try to pay attention here. Just focus here. What do? We calculate moles. We calculate moles. 18 upon molecular masses 2. This comes out to be 9 moles. What do we do next? In the stoichiometric equations, we just write the magical equation. Now, what was the magical equation? Number of moles of hydrogen upon stoichiometric coefficient 2 equals to number of moles of oxygen upon stoichiometric coefficient 1 equals to number of moles of H2O upon its stoichiometric coefficient 2. Got it? Now we just equate these two things. The number of moles of hydrogen were 9. So 9 by 2 equals to number of moles of H2O upon 2. Number of moles of water are coming out to be 9 moles. Yes. But please pay attention here. Please pay attention here. Now if you are given in the next equation 18 gram of H2 reacts with 64 gram of oxygen to form water. Alright, find moles of H2O formed. Now what you will do? You can do this question, I know. What you will do, you can simply write first this equation. You will write this equation. Got it? Now you will write whatever is given to you. 18 gram. Here also 64 gram. You need to convert them into moles. 18 by 2, 9 moles. Alright. 64 by 32, 2 moles. Now what do? Now you write how to find limiting reagent. Now you calculate limiting reagent, and then with the help of again and this thing we have studied very much in detail right now. But you try to understand what is the basic difference between these two equations. See, in this question it was given 18 gram of hydrogen reacts with oxygen to form water. There were two reactants, hydrogen and oxygen, but information was only given about one, which is hydrogen. In this given only about hydrogen you were given information means you were given mass only of hydrogen. But in this question, this is a question of limiting reagent. You are given information about more than one reactant. You are given information about two or more than two reactants. That's why it is concept of limiting reagent. Are you getting my point? Whenever information about two or more than two reactant is given, that is limiting reagent, because in that particular equation you will have one limiting reagent, other reagents would be excess reagent. All right, are you able to understand this? But if you are given only about one reactant, then it is a question of stoichiometry. Okay, if there is one reactant, you don't have any limiting or excess, you don't need to worry about it. Just simply do with stoichiometry. So I am writing here stoichiometry equations are when information means your mass, your volume, your particles, anything, when information about only one reactant is given to us. All right, and what is limiting reagent? When do we need to apply limiting reagent? When information about two or more than two reactant is given to us. Is this much clear to all of you? When we are talking only about one reactant, when question has given information means your mass, your volume, your particles, this is information, any data which is given in the question. if they have given only for one reactant, question is of stoichiometry. There is no case of limiting, excess, nothing. But if question has given you information about two or more than two reactant, then it is about your limiting reagent. This much clear to you? Give me a thumbs up in the chat section if this is clear to all of you. This is very, very, very important. This is very, very important. Give me a thumbs up in the chat section if this much is clear to all of you. Great. Kalai, Santosh, Rajni, Ritu, Richu. Is this much? Sunitha? Yes. Is this much clear to all of you? Great. Great. All right. So you need to always identify what is being asked to you. The question is of stoichiometry or the question is of limiting reagent. Those students which haven't covered the stoichiometry questions, I have very much in detail with lot of examples I have covered in our previous class. All right, you guys can just go and watch the complete lecture. You will be very much able to understand this. See, if you have any doubt, you can always in the comment section of the video, you can always ask your doubt also. I will clear your doubts there only. All right, you can surely ask me doubts also. Now in today's class, if you have any doubt, I am there for you. You can ask me. If you have any doubt, you can surely ask me. Come on. Come on everyone. If you have any doubt, tell me in the chat section. If you have any doubt. If you have any doubt, please ask me in the chat section for today's class. If you have any doubt regarding anything, you can surely ask me. See, Richu, if there is again two sequence of reaction, then also first find the limiting reagent of one first reaction and then find the limiting reagent of second reaction. This is the same thing. Mole concept, Ritu, mole concept would be completed in I think so next 2 to 3 classes. All right. Yes, Santosh, I'll summarize this thing. Please show the slide of first question. Okay. Okay, I'll just summarize this question. Limiting reagent is the one which is consumed first in the reaction. It is the first one which is consumed in your entire reaction. All right. And how do we find it? How do we find it? We find it by number of moles upon stoichiometric coefficient ratio. Number of moles upon stoichiometric coefficient. If it is lowest, that reactant is your limiting reagent. All right. Yes, Ritu, we will have our test and we will have our practice sessions also very soon. All right. Most probably in this week only we will have it. Yes. Yes, Rajni, this was our first question. You are just given information. See, whenever you see it, see, there are always, I have always given information about two reactants. See, in all the questions, I have always given information about two reactants because we were discussing today limiting reagent. All right. So this was your first question. Again, some information was given to you, and all the questions we have just to find limiting reagent and the amount of excess reagent and moles formed. All right, clear to all of you? Give me a thumbs up. Ask me more questions. You guys can ask me more questions. Come on everyone, you guys can ask me any number of questions if you have. These were all questions. This was a good question. You guys can note it down if you want. Like this video if you are able to understand everything. This was a good question. There were a lot of questions today. Now you guys can Rajni, you guys can practice questions from any book, or you are solving this. Okay, organic reaction. Yes, in tomorrow's class we'll be having organic chemistry. Okay. So see, this was again a question which we have taught, in which I have taught you how do we find excess reagent and moles formed, product, how is product formed. These all were your questions. So for some new students, I'm again repeating it, that we are having regular classes at 11 a.m. Daily we are having classes. We are studying physical chemistry. We are studying organic chemistry. Alright, one day physical, one day organic, and in between I will also take your inorganic chemistry also. In between I will take your inorganic chemistry also. Don't worry about it. Alright. Okay, now ask me your doubts. If you have any doubt, you can surely ask me. Combustion reactions, Rajni, are basically your reactions with oxygen. And if any carbon compound is reacts with oxygen, it always forms CO2 and H2O. Yes, we'll definitely be taking more examples. We'll be definitely taking more and more examples. Don't worry about it. Come on. Any other question? Yes, Kalai, yes. ER is always taken as reacted. In that magical equation, we always take it as reacted. Yes. Perfect. Great. Ask me your doubts. Come on, everyone. You can ask me your doubts. Any doubt, anything related to topic, anything not related to topic also you can ask. Is my teaching style, are you all able to understand my teaching style? Tell me in the chat section, give me a thumbs up if this is clear to all of you. My teaching style is clear to all of you. I should be able to know that whether I am teaching it good or I need to change some things. Great, Santosh, Ritu. Thank you. Great, Kalai. Great. Great, Rajni. Any doubt? If you have any, you can surely ask me. Guys, if you have any doubt, is everything clear? Everything clear to all of you? You guys can share these videos with all your friends. See, education should be for all. Education should be for all of your friends, colleagues. So you guys need to share with your friends so that everyone can come on this platform and they can be benefited from these regular classes. All right. Yes, so if you haven't yet liked the video, do like this video. Alright, like this video, hit the bell icon and subscribe to this channel. And whenever you are planning to buy the subscription, just write this Nitesh YT. Nitesh YT as a code. You will get 10% off Nitesh YT. Alright, 12-month course you will be getting at 27,000, and 24 month you will be getting at 32,400 rupees. All right. Hello, Vaibhav. I'm good. How are you? Okay, no issue, Rajni. No issue. Don't worry. Don't worry. All right. So tomorrow we will again meet at 11 a.m. I'll meet you at 11 a.m. tomorrow. All right, and we'll be studying further organic chemistry. So if you haven't studied the resonance lecture yet, please go and watch it because that is very important. We will be continuing from that only. It is on this channel only. You can search my name, Nitesh Devnani. You will have You can search there one resonance video. Just watch a very detailed video. All right. So I will see you tomorrow. Bye bye. Take care. Bye bye. Take care, everyone. I will see you tomorrow. Take care. Bye bye. Topic of tomorrow's classes, we will continue resonance and we will study about inductive and hyperconjugation. Very, very important. See you tomorrow. Great. Bye Kalai. Bye Santosh. Bye Vaibhav. Bye Rajni. Ritu. Richu. Bye everyone. Take care. Take care. Bye bye. Yes, Vaibhav. The class, we are ending this class. You can watch this video. See you tomorrow. Bye bye.